In this example, we will be simplifying the square root of 63. In order to simplify the square root of 63, we first need to review an important math concept, which is square root of a times b is equal to the square root of a times the square root of b, meaning that if we have two numbers multiplied by each other inside of a square root, we can then expand them into their own square roots with multiplication separating them. In order to apply this to the square root of 63, we must first look at the factors of 63. While there are a few factors of 63, the ones I'm choosing to use are 9 and 7, because 9 is a perfect square. And perfect squares are very important when simplifying square roots. Now we can rewrite the square root of 63 as a square root of 9 times 7. Using the rule we just established before, we can then rewrite the square root of 9 times 7 as the square root of 9 times the square root of 7. Because 3 times 3 equals 9, we can evaluate the square root of 9 as 3 and have our final simplified version of the square root of 63 equal to 3 times the square root of 7. We can also estimate the square root of 63 to the nearest whole number by looking at perfect squares near the square root of 63. We can look at the square root of 49, which will be 7, as 7 squared equals 49. We can also look at 8 squared, which is 64. As you can see, 63 lies between 49 and 64. Therefore, we can write the square root of 49 is less than the square root of 63, which is less than the square root of 64. Because 7 squared equals 49, the square root of 49 will be 7. And because 8 squared equals 64, the square root of 64 will be 8. In order to find the value that the square root of 63 is closest to, we can look at the difference between 63 and our perfect squares by subtracting them. So first we will do 63 minus 49, and we will obtain 14. Then we will do 64 minus 63 and obtain 1. As you can see, 64 is a lot closer to 63, so the square root of 63 will be closer to 8. Therefore, we can approximate the square root of 63 as 8.